This diode shouldn't have blinked, but it did. And it led me here. I was restocking my parts cabinet last week and picked up a pack of Bojack 1N4148 diodes. Standard switching diodes. Nothing exotic. Rated for 200 mA, 100 volts, fast switching, glass encased, hermetically sealed. I've used this same type in countless circuits, pulse detectors, logic gates, switching power supplies. The usual stuff. They're cheap, stable, and fast. Bojack's packaging is decent too, 125 pieces, all uniform, axial leads, color band at the cathode for easy orientation. The datasheet says what you'd expect. Forward rectified current, 200 mA. Reverse voltage, 100 volts. Low leakage, fast response. Tested under MIL STD 202 solderability standards. Nothing special, right? I first tested this batch in a basic 555 timer circuit, classic A stable mode with a blinking LED. Everything worked as expected. But then I tried something a little different. I replaced the timing capacitor with a small air gap capacitor I built myself, and swapped in a hand wound inductor. When I adjusted the diode orientation and let the inductor float for a moment, the LED continued blinking. Even after disconnecting the power. At first I thought there was residual charge on the capacitor. But it pulsed 12 more times. Consistent intervals. So I ran the same setup again, this time isolated from the bench. Same result. No battery. No solar. Just that tiny circuit, oscillating longer than it should. I've seen this before, years ago, in a file labeled v7_field_loop_sustain. PDF. It disappeared from the site 2 hours after being posted. That file used a 1N4148 diode in the feedback path of a so-called zero-drain oscillator. I'm not saying that's what I recreated. But the similarities were uncomfortable. If you've worked with pulse chargers or high-frequency flyback circuits, you know the 1N4148 can take a lot more abuse than its specs suggest. Especially when placed at the right junction between collapse and reactivation. The package I tested came from Bojack on Amazon. $5.99 for 125 pieces. Link available for specs and sourcing. No CTA. Just file it away. What matters is this. The diode didn't just switch. It echoed. It seemed to remember the pulse. That's where it started. Because this little diode led me to reopen an old box of notes, sketches, incomplete builds, odd experiments I once brushed off. One of them was labeled generator_concept_3. It used basic components. Diodes. Transistors. Coils. A feedback loop. No flywheel. No gas. No solar panel. Just energy pulled at the moment of need. From somewhere. At the time, I shelved it. Felt too strange. Too fringe. Now I'm not so sure. You see, while we've been optimizing power supplies and miniaturizing converters, others have been quietly rebuilding something different. Something off-grid. Portable. Cheap. Not magic. Not infinite. But enough. Enough to run a light. Or charge a phone. Or power a small motor. There's a blueprint going around. It's not viral. It's not mainstream. But it's real. It walks you step by step through building a working off-grid generator. Under $200 in parts. Using materials you can find at any local shop. It doesn't require an electrical engineering degree. And it doesn't promise miracles. But what it does offer is independence. Not just from the grid. From the illusion that this is as far as we're allowed to go. The ultimate off-grid generator blueprint is based on rediscovered technologies. The kind once attributed to Tesla, then quickly buried under decades of modernization. You won't see it in school. But it works. It's already being built. And when you feel the circuit hum to life, not from stored power, but from clever resonance, you'll know. You'll know that the diode was only the doorway. I'm not linking it here like a product. Because it's not. But I've left a symbol. A token. If you're just looking for a fast switching diode, scroll past. You already got what you came for. But if something in your hands remembers. If something in your memory twitches when a circuit pulses with no power. Then maybe. Just maybe. You were meant to build this. Because some energy was never lost. Only locked. And now, piece by piece, we're finding the keys.